Welcome to qnawire.
So on a normal day, your velocity on your trip home, v, is 105 kilometers per hour. And the trip time, t, is 2 hours and 20 minutes, which I converted just into hours since there are 60 minutes in an hour. 2 hours and 20 minutes is the same as 2 hours times 20 divided by 60, right? So then that is 2.33 hours. And the velocity on a slow day, v prime, is 70 kilometers per hour. And we want to figure out the difference in the time it takes when you're only going 70 kilometers per hour versus going 105 kilometers per hour. One thing to consider in order to do this is the distance you're traveling in both situations is the same. So d is equal to d prime. So we're going to use that to go ahead and solve this expression. So distance is equal to the velocity times the time. Therefore, the distance on a slow day, d prime, is going to be equal to the velocity on the slow day, v prime, times t prime. We need to find t prime in order to find the differences in the times. But we said that d is equal to d prime. Therefore, v prime times t prime is equal to v times t. So we can use this to solve for t prime. We find that t prime is equal to, let's draw that a little nicer. T prime is equal to the velocity times the time divided by the velocity on a slow day, v prime. Plugging in those values in this expression, we find that this is equal to 3.5 hours. But 3.5 hours is the same as 3 hours and 30 minutes. So we can write this as 3 hours and 30 minutes. So now that we know t prime, we can figure out how much longer it takes on a heavy traffic day versus a low traffic day. So delta t, our difference in the times, is equal to t prime minus t. So for t prime, we use 3 hours and 30 minutes, and for t, we use 2 hours and 20 minutes. So we find the difference is 1 hour and 10 minutes. So it takes 1 hour and 10 minutes longer to get home on a heavy traffic day versus a slow traffic day. And we can box that in as our solution to the question.